to graph a function involving more than one transformation, we can graph it by performing transformations in the following order. First, horizontal shifting. Second, we look at the vertical shifting. Third, we look at reflections. And fourth, we look at vertical shifting. So let's look at a few examples of this. Example, sketch the graph of y equals -2, parentheses, x minus 4, close parentheses, squared, plus 3. First thing we need to observe is actually the parent function. All right, the parent function is f of x equals x squared. We're looking at a quadratic, and we're shifting and stretching that. So next we have horizontal shifting. All right, so we have 4 units to the right. That one is always backwards from what you think. We have a -4, which you might think is to the left. So we're going 4 to the right because we're looking at the value after the minus sign. That is a positive value after the minus sign, so therefore we are going to the right. Next, we would look at a vertical stretch. So vertical stretch, we have a factor of 2. Stretch by a factor of 2. Next, we have a reflection, because we have that -2. And last, we have a vertical shift up 2 units. So let's begin modifying the x squared function. I'm going to try to use several different colors for this. So first we have this to the point 0, 0, 1, 1, 2, 4, 3, 9, and it is an even function. So we have a reflection about the y-axis. I'm not going to connect these because I am going to apply several transformations. So I'm going to shift this 4 to the right. So use an orange. Shift each of these points 4 to the right. So we will have 7, 9, going from right to left. We'll have 6, 4. You'll have 5, 1, and 4, 0. And then because it is symmetric, we will have the rest of those points up to 0, 9. So we have 0, 9, 2, 4, and 3, 1. Now we're stretching this by a factor of 2. So the y values will double. So we have 4, 0 remains where it is. We have 5, 1 becomes 5, 2. 6, 4 becomes 6, 8. Actually, let me use same color, but let's put x's for these new points. And because it is symmetric, we will have 3, 2. We have 2, 8. All right, we have those 5 points. Next, we're reflecting about the y-axis. So these all will flip across the x-axis. We still have 4, 0. But now instead of 5, 2, we have 5, -2. Because instead of 3, 2, we have 3, -2. See, our next point was 6, 8. So we have 6, -8. And also 2, -8. Last, we need to shift up. Did I really write plus up 2 units? Up 3 units. So we'll shift this entire function, those dark blue points, shift them up 3 units. So now I'm at 4, 2. I am at 5, 0, 3, 0. Oh, wait, hold on a second. All right, I didn't change that correctly. All right, we want to move up 3 units. So I'm at 4, 3. I'm at 5, +1, 3, +1. Up 3 units from -8 is -5. So we have a point at 2, -5, and 6, -5. Now I am going to connect these. And I definitely suggest that you re-watch that process, because we're going to do one more example but there's a lot of thinking going on in there. But you want to go in that order. Our next example, sketch the graph of y equals negative 1/2 times square root of quantity x minus 2. First, the parent function is f of x equals the square root of x. We'll begin with that. I'm going to go ahead and plot some points for that. That is 0, 0, 1, 1, 4, 2, 9, 3. Now, going in the order we stated, horizontal shifting, this moves 2 units. Again, we have a minus 2. That is a positive 2, so we're going to the right. After that subtraction sign, we have a positive sign. 2 units right. We have a vertical stretch. Okay, stretch by a factor of 1/2. So this is actually a shrink. Next, we have a reflection. Reflection over the x-axis. Last, we have vertical shifting. Oh, we don't actually have vertical shifting, so we don't have to worry about that. We don't have a plus value at the end. So beginning with our parent function, those light blue dots, I'm going to shift these 2 units to the right. 2 to the right. So from 0, 0, I now have 2, 0. 1, 1, I now have 3, 1. So from 0, 0 to 2, 0. 1, 1 to 3, 1. From 4, 2 is now 6, 2. And my 9, 3 will now be at 11, 3. So now I'm on dark blue. Now stretch by a 1/2 factor. So we're shrinking this function. These are going to be half as close to the x-axis. So 2, 0 is still there, but now we have 3.5, the coordinate 3, comma 0.5. The point 6, 2 becomes 6, 1. The point 11, 3 becomes 11, 1.5. And let's see, the 2, 0 stays where it is. Now we reflect this across the x-axis, and this is our last transformation, so I'm going to do these in black. 2, 0, 3, and then negative 0.5 because it was positive 0.5. 6, negative 1 because it was 6, positive 1. And 11, negative 1.5 because it was 11, 1.5. And there is our resulting transformation.